In this video, we are going to find prime numbers p and q such that p cubed plus 3 times q cubed minus 32 is also a prime number. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. We can find all solutions to p and q with one simple trick, which is to notice that these two terms, p cubed and q cubed, since p and q are prime numbers, they're actually, for most of the time, odd numbers. So that means p cubed is mostly odd, q cubed is mostly odd, and hence 3 times q cubed is also mostly odd. Now, for two terms that's mostly odd, the sum would be mostly even, and that sum subtracted by 32 would still be mostly even. But this expression has to be a prime number, so the only possibility for these, for the most general cases, would be p cubed plus 3q cubed minus 32 equals 2, the only even prime number. And this happens for all primes p and q, that's at least 3. And so we are going to solve the equation p cubed plus 3q cubed equals 34. However, for prime numbers p and q that are at least 3, but is at least 3 cubed plus 3 times 3 cubed, and that's 108, which is way larger than 34. So that means there is no solution when p and q are both odd. Now what remains would be just either p equals to 2 or q equals to 2. Well, of course, we can also consider the fact that, I should say, the possibility that p and q are both even, but that will not be a valid solution, because if p and q are both 2, then the given expression will be equal to 0, clearly not a prime. So now we have to go back to the case that either one of them is equal to 2. If p equals to 2, then 8 plus 3q cubed minus 32 is prime, which means 3q cubed minus 24 is a prime number. But for this expression, we can factorize that as 3 times q cubed minus 8, which has to be a prime number. And so that means the only way is that this expression q cubed minus 8 equals 1, but then q cubed equals 9, so it's not possible. Then we have only one case left, which is when q equals 2. Then p cubed plus 3 times 2 cubed minus 32 is prime, which means p cubed minus 8 is a prime number. This expression can be factorized as p minus 2 times p squared plus 2p plus 4. So clearly, p squared plus 2p plus 4 is larger than p minus 2, since prime number p is also a positive integer. So the only way for that to be a prime number is that one part of the product is 1, which means p minus 2 has to be equal to 1, so p equals 3. Now let's check whether p equals 3, q equals 2 is a valid solution pair. Indeed, p cubed plus 3q cubed minus 32 equals 27 plus 3 times 8 minus 32, and that's 19. Indeed, a prime. So that means p equals 3, q equals 2 is a valid solution, and this is the final answer. Please feel free to share ideas in the comments. Thank you for watching. See you next time.